No one reads your tweets. You got like 10 followers. It's okay. I didn't get a lot of followers until I actually started tweeting.
Are you gonna be all right, man?
Yeah. I'm bueno.
All right. Yeah, you can put it in there. That's fine. I don't think it's gonna hurt anything.
Hey, you know, racing stripes, look like that. Look like he's coming around that corner. I was no Coach Willie is that. He's just gonna laugh.
Everybody else did.
Oh,
I think I'm making these nice right there. Just passing your hand. All right, listen. Your notes today, this is what we're gonna do. On your bell ringer vocab, I don't think you have a box that says absolute value. Just go ahead and write it in your notes as it is right here, and then make sure that you draw the key concept on there because that's probably the most important part. Okay, that's where we're gonna work from. Okay, you guys know what the absolute value of something is, right? Okay, absolute value of a negative. What's the absolute value of -2? 2. It turns into positive, right? Absolute value of 2 is 2. No, it's always positive. What's the absolute value of 4?
4.
Absolute value of -5.
5.
Absolute value of 10. Okay, so it always turns into positive, right? Okay, so absolute value functions is another type of piecewise linear function. And you'll get into more piecewise linear functions in Algebra 2. Okay? It's the absolute value function. Recall that the absolute value of a number is always what? What did we just prove? It's always non-negative, which makes it a positive number. Okay, so the absolute value of the parent function, it's written as f of x equals absolute value of x. All values of the range are what? Positive numbers. What does that mean? They are all above what? Yeah, if I were to graph it though on a graph, it would be what? All my y values will be greater than what? 0. Good. You guys see that? Make sure that you draw the box. This is probably the most important part right here, because we're going to work off of it. The parent function is f of x equals absolute value of x, defined as x if x is greater than 0. F of x equals 0 if x is 0. Okay, so there's my graph right there. That's the parent graph. It's always going to, every graph that we graph after this point is going to stem from that graph. Okay? Yes, ma'am. No, that's okay. I mean, is she here? No, it's not. I just needed to talk to her about a student. It's not an emergency, though. I'll just send her an email. Okay, thanks. Okay, this type of graph is going to make a V shape. The domain of the parent graph is all real numbers. What's the domain? It's our x's, right? Okay, so from that point right there, I keep going where? To the right, don't I? Okay, because my arrows just keep on going, going, going. And I can also go to the left. And in this case, all of the range is going to be all non-negative real numbers. That means it goes above 0. Everything above 0. So how could I write that? Domain is x is greater than 0. All non-negative, x is what?
Less than 0.
Less than, no, it has to be greater than 0, right? If it's less than 0, it'd be a non-negative number, right? Or it'd be negative.
I don't know. I'm confused. This is a new subject.
It's algebra.
I know. But it's so confusing because I haven't learned this in a while.
Well, you might want to write this down like I asked you to. That'll help. Make sure you draw your diagram. we're gonna talk about.
We're gonna make some notes on it, actually. Only 2 gone today. Somebody's phone's going off. That's mine. Okay, you guys got that? Are you needing more time, or?
All right, let's make some notes off of this. First thing you need to understand is, I've got f of x. You have to treat this, when it has the lines, the absolute value lines on the side of the x right there, you have to treat that whole thing like one variable. You guys listening to me? You gotta treat this whole thing like a variable. Write that down. You have to treat the whole thing like one variable, one value. Okay, now, the next part is, if I treat it like a variable, what's always understood that I can put in front of it if it's not there? A 1, good. So I can put a 1 in front of that. Write that down. You need to know this. Okay, so this turns into my slope. So I can write that 1, how else can I write it? 1 over 1. Everybody got that? Okay, now there's a couple different ways, or a couple different methods we can use to graph these lines, these absolute values, okay? I'm going to show you both of them. First one we're going to start with is doing an input-output table, all right? So write this problem down right here. graph f of x equals absolute value of x minus 4. We want to state the domain in the range. Okay, since f of x cannot be negative, the minimum point of the graph is where f of x equals 0. Write that down, I'll have to go back. Give me a little time. And the first step in step 1 is we want to find the vertex. And I'll show you what the vertex here is in just a sec.
See, there's people that do what they're told, and there's people that just act up to get a reaction. To get a reaction.
No.
He doesn't baseball, he doesn't really get that, so he doesn't care about it.
There's
Because I
that,
think very definite.
there's, yeah, no.
There's a lot of people that just hear this.
Sorry about that. Guys got all that down?
Yep.
Okay. Go to the previous slide. All right, now, what is the vertex? Anybody know what the vertex is? What is
Isn't
that?
that the point of where the two lines meet?
Yeah, right down here at the bottom is the vertex. Okay, that's where everything starts from. Okay, notice my lines are going where? From the vertex, lines are going up. Okay? So we also refer to that point as, in this case, it's the lowest point, isn't it? Okay, so it is also referred to as the minimum. What if my lines were going down? Then it'd be the maximum, good, okay? So write that down on the side. If lines are facing down, vertex becomes the maximum. You'll hear that terminology in some of your higher math classes. Minimum, maximum. Guys got it? Okay. All right, so now going back to our previous problem. First step, okay, this is the first way I can graph these lines. The first thing we want to do, step one, make sure you have it written down, is we need to find the vertex. All right, now make sure that you pay attention and you watch this because this gets a little tricky, okay? The first thing, since I know it cannot be a negative number, the minimum point of the graph is where my y value, f of x, is the same thing as y, isn't it? Okay, write that down. Make sure you write that down. So all my y values are, it's going to be, the starting point is going to be 0, right? So where's the start on the y-axis? I know that, okay? If you notice, there's nothing outside of the absolute value, is there? Okay, so whatever x is, my y value is always going to be what? A positive number, good. But my vertex is going to start where? On the x-axis, right? Okay? So I can say that my y is going to be 0. Okay, so now, what I want to do, you guys watch this, it's a little tricky. I'm going to take this middle part right here, and I'm going to bring it down here. Okay, now, based on what we said y is going to equal what?
Yeah.
So for, instead of f of x, what would I put? Exactly, good. Who said that? Okay, so instead of f of x, I'm going to put 0. Now, you got to understand, what are we trying to find here? We're trying to find the vertex, right? Which is a point, isn't it? Okay? So I can write it as an ordered pair, right? Okay, so do we know my y coordinate? We said it was what? 0. So now all I got to do is find my x coordinate, okay? How do I do that with the way it looks right now? Good, add 4 to both sides. So x equals 4. Okay, so now that's where my graph is going to start, right? Okay, do we know what our slope is here? Yeah. Remember, we treat that whole thing like one variable, one value, right? What's in front of the absolute value? Is there anything there now? So it's understood that I can put a 1 in front of it. So my slope will be 1 over 1. We'll need to know that for later. Okay, now another thing that you guys can do is I can always define this part right here, because you're going to have some numbers outside too and some numbers in front, okay, which is going to move your graph around a little bit. So in some cases, you may have to take, whenever you pull that out and set it equal to 0, you're going to have to plug it back into the equation. I didn't do it here because it just kind of falls into place. But if I were to plug it back into my equation to find this y value, what's going to happen? It's still going to do what? If I put 4 in for x, what's 4 minus 4? What's the absolute value of 0? It still comes out be the same thing, doesn't it? You guys with me on that? Okay, so now coming back over here. We found the vertex, that's my starting point. My vertex is gonna be where? 4, 0. Everybody said that's where everything starts, right? So I'm gonna plot a point on 4, 0. So I want to do that on the graphic that I gave you. And right below it, you notice you have some lines right below it, right? I write the function underneath that graph also. Okay, so now, step 2 is we want to determine the slope. What's the slope of this line? It's going to be 1, right? So the slope is 1 over 1. That tells me how I'm going to count my squares. The other thing that you need to know is you need to know the axis of symmetry. If I were to take that graph, this V that I've got, and I cut it in half and fold it over, what do you suppose is going to happen? Yeah, it's going to match up, isn't it? Those lines on each side, what are they going to do? They're going to fall on each other, right? They're going to fold over. So the axis of symmetry, once I get the vertex, it's a line that goes right down the middle. That's called my axis of symmetry. And basically what that means is, if I plot a point over here, what's going to happen on the other side? How far is that point from the axis of symmetry? 2 squares, right? So what's the point on the other side going to be? It's going to be 2 also. I can take this V and do what? Fold it in half the axis and both sides will match up. I just counted my slope.
Oh.
What's my slope for my vertex?
21.
So I go up 1 square, right 1 square, up 1 square, right 1 square. So I can make all kinds of points right here. Okay? And I can do the same thing on the other side. What's the other side going to be? Is it going to be the same slope? Yeah, up, left, up, left, up, left, up, left 1 square, up, left 1 square. And there's my V. You guys see how it's taking shape? Okay? Alright. Now that's pretty easy. I can also write these two down. Step 4 is I can find some ordered pairs. Now based on what I told you on the axis of symmetry, what did I say? You can fold over each other, right? Now, I will tell you this. Is this table any different than this table?
No.
Most people prefer this table right here when they're doing absolute value. Because I need to put in the middle, what goes in the middle? The vertex, very good. So if I put 4, 0, what's going to happen to this table over that vertex? It's going to fold over, right? Okay, so what's the next point to the left of 4? It's 3. Because it is in function form, right? I have a dependent and an independent variable here, right? Okay, so I can do this. The rule tells me I can do this. What's the next number to the left of 3? Okay, what's the next number to the right of 4? What's the next number to the right of 5? 6. Okay, these are all my independent values. I think that's good. All right, so now, at this point, I can go ahead and plug some numbers. Now, I'm going to plug all of them in so you can kind of see what's happening here. Start with the 3 first. If I put 3 in for x, what happens? What's 3 minus 4? -1, what's the absolute value of -1?
1,
So what's this value?
1,
1. Okay, put your 2 in there. 2 minus 4 is what?
-2,
What's the absolute value of -2?
2,
Okay, now do your right side. Put 5 in there.
1,
5 minus 4 is 1. What's the absolute value of 1?
1,
6 minus 4.
2,
Absolute value 2.
2,
Do you see a pattern? What's the pattern here? Once I determine the vertex right here, what happens to my y's or my f of x's? They match up, don't they? But what did we just get through saying? That was the line of what? Symmetry. So if I fold this over, then my y's are going to do what? They got to match up. So if you want to do it like this, then all you got to do is for 2 values, and then they're going to match up on the other side. Is everybody clear on that? Okay. You got to be careful on your x values. Why? Because what is my graph doing from that on my x values? It keeps doing what? Going left, keeps getting what? Wider and wider. You guys with me on that so far? Okay. If you understand that, then you got that down pretty good, then you're going to be in business. All right, move on. Can I go further? Okay. Next slide. Here's another way. This is probably the easiest way. And you guys will probably prefer this way over the other way. I don't know. Okay, we're going to go over it anyways. We can also graph these lines based on translations. Okay, example 2, translations of absolute value. Remember I said you have a what? A parent function that everything works off of, right? Look at this, write this down. My parent function is y, this graph right here in blue, that's what? Y equals absolute value of x. Well, what happens if I throw a negative in front of the absolute value? What's it do to my graph?
then it's maximum,
Yeah, then it just flips down and makes the vertex what? The maximum. It's still 0, it just makes it a maximum. So notice, how does the blue right here, still, vertex is still 0, 0, okay? It just flips it down is all it does. Guys see that? Okay, so a negative in front flips the graph down. Does my slope still stay the same? Yeah, I'm still going down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, so on and so forth. There's my points. Down 1, right 1. Still doesn't stay the same. It's the same thing on the other side too. Down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. Guys got it?
Yeah.
Some people are still right. Okay. That's you good? Need some more time?
I got it.
Anybody else need more time?
Just a bit more. What's today?
It's 28th, I believe. Did she say she?
Are you gonna use computers today? Or just taking it?
I'll take notes probably. I don't think we'll have time to get the quiz in, but we'll get it later. Probably next week sometime. Okay, here's the next translation. Okay, you got your parent graph. If I have a number inside the absolute value that comes right after the x. In this case, it's a -1. This is going to move it how? Okay, so it moves in the opposite direction. However many squares. So if it's a +1, it moves it. If it's a -1, it moves it right 1 square. What if it were a -5? How many squares would it go? They go 5 squares to the right. Everybody clear on that? If it's a +1, then it moves it how?
To the left.
Very good. Left. Got it? What if there's a number outside of the absolute value at the end? What direction is this going to move? Very good. That's going to move up 1 square. Now what's moving? The whole graph or just 1 point? The whole thing is moving up. The whole graph is moving up 1 square. Okay? As opposed to the other side, if it's a -1, -1, moves down. What happens if I have a number in front?
Then it changes to me.
Yeah, it changes the slope to v, right? If it's a whole number, like 2, 3, 4, 5, 6, 7, the bigger it is, what happens to the graph? This is what happens. It starts to do what? Close it. Okay? So the bigger the number is, the steeper my, or the more narrow my gap is. Okay? So now, we said that that is my what? Slope, right? So on my vertex, what I do is now I'm going to count. Up to, over 1. 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 Up to, so on and so forth. Can I see that? Okay, so if it's a fraction, what does it make the graph do?
One.
Yeah, right. Opens it up. Okay? Do I still count the slope the same way? Yeah. From the vertex, I go right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1. Left 2, up 1, left 2, up 1, left 2, up 1, so on and so forth. Guys see how that works? Right, any questions on that? Pretty simple, right? Pretty easy. Yeah, just use the same plug. What?
It's racing stripes with very.
And how does Tim,
We're gonna watch that movie next time we come over.
What happens when you throw a bunch of those scenarios together?
You get lines going all different directions.
No.
You get used to
Yeah.
No, no. Just follow your rules. Write that down on one of your graphs. So then we got a whole bunch of different scenarios here. You have to understand though, my parent graph is where? It's still what? The same, no matter what. Okay, so there's my parent graph. So now, what is what does that do to my graph? Right to what? 2 squares. So my birthday goes right 2 squares, and then it moves what? Down, good.
Wait, I thought that would make it move left.
No, check your notes. Oh, I'm sorry, yeah, left is,
Yeah.
this is left, opposite side. Down 3. So we go left 2, and then down how many? 3. Okay, the slope now is gonna be what? 2 over 1. I'm gonna go up 2 squares, right a square. Up 2 squares left, symmetry, right? Up 2 squares left, up 2 squares left at 1.
What did it go right because it's alternate?
No,
It goes left. It goes in the opposite direction. So I wrote that wrong. So left 2 squares.
So on all of them, they always go in the opposite direction.
Do what now?
They always go the opposite direction.
Yes. I'll show you a scenario when it does here in a sec, okay? What if I put a negative? What if I had a -2 in front of there? What would happen to that graph in red?
it would flip.
Oh, it would.
It'd be facing down. But I still count my slope and everything the same way?
Yeah. It would be.
Yeah, the vertex would turn into a maximum. Hey, look at number 1 on your card check. Pretty easy. What happens to the parent graph? Moves right. Okay, so starting at 0 at the vertex, move. My slope is up 1, right 1, up 1, right 1. Axis symmetry, gonna be on the same side. Okay, now look at number 2, real quick, because you're gonna see something like these two kind of throws you off a little bit. Now, is there anything outside of the absolute value?
No.
So is my graph gonna go up or down any?
No.
No, it's just gonna stay on the x-axis, okay? So now, if that's the case, and I know that my f of x is gonna be what? It's gonna be 0, all right? I can take that middle part. Now, the way it looks right now, which direction would you move it? Based on what we talked about.
Down.
No, what's the +2 movement?
Oh.
Moves it left 2 units, right? But if you notice, what do you have in front of that x right there? Okay, so this kind of throws it off a little bit. If I pull the middle out and set it equal to 0, watch what happens. I don't get x by itself. Divide by. So what's my vertex? 2 and 1. Which direction did you guys say to move it?
Left.
You said move it left, but in reality, it should be going what? Okay. Yeah. So the negative in front of the X. Now notice, where's the negative? Is it outside?
It's inside.
It's inside the absolute value in front, right? Okay, so this changes this from the opposite direction to the direction that it is right now. You guys clear on that? That's probably the most commonly missed part right there.
And so it's just gonna be on the X, that's it.
Yeah. So it'll lie on the x-axis. And then can I do everything else the same?
Yeah.
Yeah. Up one, right one, up one, right one, up one, right one. Axis of symmetry. Just like so. Now look at 3 and 4. 3 is going to move it
Down.
down good. 2, 3, 1. Moves it down. And number 4. Left. How many? 5. So 1, 2, 3, 4, 5. Now sometimes, you guys watch this real quick, don't be confused by this. You guys understand that this coordinate plane does what? It keeps going, right? It's growing, right? Okay, so sometimes you'll see absolute value graphs like this, and people get confused. People get confused sometimes because they only see one side of the line. You know what I'm saying? When in reality, this is still what? It's still a absolute value. You just don't see the other side of it because my coordinate plane is not extended out. Okay? The key is when I graph, and this is kind of what you got to pay attention to. When I graph that line, what do you notice that one end had and one end didn't have? You said it, Brad. Say it louder. An arrow. This end right here, does it have an arrow? What is that end? It doesn't have an arrow, does it? So you got to start thinking in your head, hey, this may be a different graph than just linear, right? If it's a linear graph, what would happen?
It has 2 arrows.
It has arrows on both ends, wouldn't it? You see what I'm getting at? Okay. So pay attention to that. That actually means if I just have a point with an arrow, it actually means that you probably have another line coming out the other side. Okay? Just kind of watch for that. Just because there's not another line on the other side doesn't mean it's not an absolute value. Any questions? Yeah. Okay, domain. Now look at this one. What's the range on this one? Where's my birthday start? -3. So all my y's would be what? That'd be above 3, wouldn't it? Okay, so the range would be y is greater than or equal to what? -3. So all my y's, basically all my y's are greater. What is it? What's my domain? It's always going to be this in every case. What's my domain? Keeps going, right? Left and right. So it's all what? All real numbers. And that's going to be true on every one of them, isn't it? Okay. What's your range here? Y is greater than what? What would your range be on this one?
1 and 0.
Which range on that one? So both of them are laying on the x-axis.
So E, before the Y be zero? Or would the domain?
Domain would be all real numbers.
And then the, range would be zero because,
How does my graph keep going up, doesn't it? Okay, so I gotta include all the numbers that are above what? Zero. Okay, so Y, all my Y values are gonna be greater than zero.
When the greater than one because your function says.
Now, what happens here, if you put greater than one, you miss all these numbers here. Got it?
Oh, this one is zero.
Race keeps going.